What's up, mathletes? Let's do this. All right. So today's EQ is what is the connection? What is the connection? And we're going to look at how to solve and graph quadratic equations with multiple different representations. And it's all going to stem, if you look right above this lesson, you'll notice a different section that I normally don't have there. It's the word problem that I'm getting this all from. For those of you writing notes, no, I do not want you to write that word problem down. That would be ridiculous. I just want you to have access to it, okay? What you do have to do is make this graph. And so I've got this printed out right here on the paper that's nice. If you don't, what you're going to need is a 45 by 20. Okay, what do I mean by that? Well, I mean you're going to need to have 45 tick marks up and at least 20 over to the right. 20 over, I guess going this way. Sorry, my camera is not mirrored. To the right. So keep that in mind. And let's go ahead. So I'm going to scroll this up so you can just see me as I go ahead and fill it out real time with you. The first thing is we're going to label this. This is going to be my height. And that's in yards. Height in yards. Remember, a yard is 3 feet. I should probably write that. 1 yard equals 3 feet. Just in case anybody needs to know for any particular reason. And then down here, and this, by the way, is, of course, my y, right? We want to label that up here, y. And then for my x, let me move that out of the way. Can I move those controls out of the way? I don't know. Yes, I can. My x-axis down here. And this is going to be my distance, and that's in feet. And I've actually got a bunch of boxes down here, so I'm going to show you what I do here. Going up, I'm going to label it by 1, so we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 20. This little bit of setup will be worth it. 23, 24, 25, 30, 35, 40. All right, good. Really only up to 40, I guess. That's the highest I really need it, not 45. And then in feet, since I have the extra room, guys, I'm only going to do every 2 is 1. And because of that, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It just helps spread out the graph. 11, 12, 13, 14, 15, and then 16 and 17. And if it helps you guys, you know what? When it's spread out like this, sometimes I just write them all. 1, 2, why not? Only when they're spread out that I do this. It just helps my mind track a little better when I'm graphing. Awesome. And that should be enough. Okay? Now I've got a book beside me I'm going to be reading from, but everything I'm reading is right above the lesson in the Canvas page, so you can read it. And it says this, it says, every year Newton High School holds a water balloon competition during halftime of their homecoming game. Each contestant uses a catapult to launch a water balloon from the ground on the football field. This year, you are the judge. You! You must decide which contestant wins the prize for longest distance and highest launch. Fortunately, you have a computer that will collect data for each throw. The computer uses X to represent horizontal distance in yards from the goal line and Y to represent the height in yards. The announcer shouts, Maggie-nanimous. Oh, these names are corny. They're cheese big time. But we're going to call her Maggie. Maggie. Maggie Nanimus, you're up first. She runs down and places her catapult at the 3-yard line. So she's going to place her catapult right here. Boom. We know the first point, 3-yard line. And after Maggie launches, the computer reports that the balloon traveled along the parabola represented by the quadratic equation y equals negative x squared plus 17x minus 42. Well, we need to take this equation, so Maggie's launches at y equals negative x squared plus 17x minus 42. And because it's a negative x squared, here, I better scoot this up a little bit now that we've filled this in. We know a couple things. Number one, I know if it starts here, it's going to go up and eventually come back down, because remember, it's an upside down parabola, right? Another thing I know, I'm going to have to make an xy table. We got to take this equation, we got to graph it out. And I already know that 3 is my first 0. So I'm going to start up from 3, and I'm going to go to 4. So I already know where to start from, right? 3 is my starting point. So they at least help us out there. So let's plug in 4. And what do I mean by plugging in? You're going to plug in y equals negative 4 squared plus 17 times 4 minus 4. A little tedious, and yet oh so necessary. And let's go ahead and graph a few points. So, what am I going to have here? Well, 4 squared is 16, and that's going to make it a negative 16 because the negative's on the outside, right? Plus, what's 17 times 4? Well, that's 40 and 28, 68, minus 4. So I have minus 16, minus 4, that's minus 20. What's 68 minus 20? Well, that feels wrong. Is that supposed to be 17x? Because something feels super off about this. Oh, minus 42. Oh, that's where I went wrong. Hey, sometimes you got to figure that out. I was like, something's going to be real big here. So again, okay, what's 16 plus 42? Well, that's negative 58. What's 68 minus 58? Well, that's 10. Okay, that's more in the ballpark. All right. And let's go to 5. Trust me, this is actually going to be easier than you think. You're going to do the same thing. Y equals negative 5 squared plus 17 times 5 minus 42. Okay, so again, that's 25 minus 25. We're going to have negative 25 plus, that's going to be 85. 5 times 10 is 50. 5 times 7 is 35. Add them together is 85. And then minus 42. And you're welcome to use a calculator. I got to be honest. Although I can do some of this in my head, I don't really feel like it at this moment. So I'm going to have 85 minus 25 minus 42. And what does that give me? 18. So that's 18. Boom. 18. Okay, that looks about right. Let's go to 6. At 6, what's going to happen here? I'm going to have, and I should probably start writing these numbers close together because I'm going to run out of room if I don't, and I don't want to run out of room. But what do we have? We have y equals negative 6 squared plus 17 times 6 minus 42. And if you want to use a calculator, don't bother me. But we're going to get that. So we're going to have negative 36 plus, let's see, 60 and 42 is 102 minus 42. So that's going to be 60 minus 36, or 24, I think is what we're looking at here. Sounds good to me. So let's see, 7. And you'll notice it's slowing down. It went up by 10, went up by 8, went up by 6. I wonder if this one's only going to go up by 4. Wouldn't that be a nice little turnaround for us? So we're going to have y equals negative 7 squared plus 17 times 7 minus 42. And what's 7 times 17? So we're going to have, which equals negative 49 plus 119 minus 42. And what's 119 minus 49 minus 42? Gets me 28. Oh, that looks about right. Hey, look at that. It did only go up by 4. What do you bet the next one's 30? I think we've cracked the pattern here. 8. I'm going to have y equals what is it? Negative 8 squared plus 17 times 8 minus 42, which equals negative 64 plus, let's see, 80 and 56 is 136 minus 42. I bet you this is going to end up being 30. We're going to have negative 64. Oh, no, I did it wrong. Sorry, 136 minus 64 minus 42. What do you know it? It's 30. And because we're in the interest of time, I will just tell you 9 is going to get 30. And so what does that mean for us? That means that 10 is just going to reflect 28. 11 is going to be 24. 12 is going to be 18. 13 is going to be 10. And 14 is going to be 0. It's important that we know this because it's just reflecting on the way down. Sorry, I know that's hard to read because I started writing so small, but that's just 18, 10, and 0. So now we can get to graphing. So let's get to graphing on this. And you're not going to see everything I'm doing. But I do know we're going to have 3, 0. 4 is going to go up to 10. That's why I have a nice grid here. 5 is 18. 6 is 24. There's 20. 1, 2, 3, 4. 7 is 28. 5, 6, 7, 8. And 8 is 30. And then I know that it's going to be 30 again. And it's just going to reflect that. So it's just going to build that on the way down. See how it's just reflecting straight across from the other one? Ooh, got stuff falling down. And so when I get down to here, it's just going to reflect. Go over to, it's going to reflect. Sorry, sometimes it's hard to see the lines. And then we go down to 0, 14. Look at that. And so if I were to graph this line, which I'm going to very wisely do with a pencil, it's going to be this nice little something. We're going to get to what that something is. It's not just going to flatline right there, guys. It's going to go up. So what we can do is we know what's the number right in between those 2 points where they're the same. It'd be 8.5. If you plug in 8.5, so at 8.5, here, we'll just finish our little table over here. At 8.5, we're going to get, I think it's 30.25, I think is what we end up getting. I did it on my own on another piece of paper. Yeah, it's 30.25. 30.25. So really it just goes up just a little bit to about right there. And that's our vertex right there. So what do we do? When we found that two numbers are identical, remember? I'm sorry, you can't see that. When you have two matching values of y, it's just in between is going to be where the vertex is. And then, just to help you guys see this, and I would recommend if you guys have some highlighters, this is a good route to take. I'm just going to highlight that. And this is the path of magnanimous. So mag. The Megster. And then let's read. I just wrote her name and labeled it. Okay? So we see it went from 3 feet to 14 feet. So this one traveled a total of 11 feet. That's pretty good. Let's read about the next person. The next person is Jen Eris. Jen Eris. We're just going to label this Jen. Jen. And you'll see the picture up above. It actually shows us what the graph looks like. But ultimately, we have a graph, and we're going to draw it on here, that starts off at 0 and ends at 8. At 4, so ends at 8, starts at 0. At 4, tops out at 32. And so again, I'm just going to use my pencil to draw this all the way. Maybe I'll zoom out just a tad so you can see it all at the same time. So it's not bad, not terrible. Could have done worse. And this is Jen. Jen went from 0 to 8, so it traveled 8 feet. Max height to 32 feet, where Mags was a max height. Mags went longer, but only went up to 30.25 feet. And we probably should label this as Jen. It's my wife's name, Jen, so I'll get down with that. Go, Jen. All right. So not a lot of information about Jen. We just drew it. Graph was given. So we just used a graph for that information, right? Graph was given. Let's go to our next person. Our next person is a little different. They're going to give us a table of values. And the third contestant is impeccable. Impeccable, so imp. I'm going to call this imp. All right. And imp, if you look above, go ahead and draw it in the box here. They give us, we have our X, which is in yards, and our Y, which is in yards as well. And by the way, I wrote up here feet, and I meant to write yards. Would you guys forgive me? I just realized that mistake. That should have been yards up here. Yards. Like yards. It's a good. That's terrible. Let me just write yards. Please forgive me for writing feet. I realized that mistake as I was going through it. So my Y's in yards and my X is in yards, okay? So let's do this. Are you ready? That needed a little extra room right there, so we'll do this. And I might need some extra room down here for this table to keep going. We'll see what happens. It's not my finest table. I feel that. I feel that. And if you look, it tells us that it's 2, 3, 4, 5, 6, 7, 8, 9. Didn't even need that extra part. And at 2 yards on the X, we're at 0 on the Y, so that's starting at 2. And then it goes 9, 16, 21, 9, 16, 21, 24, 25, 24, 24, 25, 24. Zoom in on that for you, in case you're just writing it with me. And at 9, it is 21. So we do got to keep going, right? So we're going to have 10. 10 will go back down. So if it went 25, 24, 21, 16, so 16. 11 will go down to 9, right? I'm sorry, yeah, 9. And then 12 will go down to 0. So this one is going between what? It's going between 2 and 12 feet. So this one travels or yards. So this one travels a total of 10 yards. And let's zoom back out again because we're going to graph our points here, right? What does it tell us? It tells us that it's 3, 9. So 3 is going to go up to 9. 4 goes up to 16. So 15, 16. 5 goes up to 21. So 21. And then 6 is going to be 24. So 24. Oh, we have some crossage there with Maggie. 7 is going to be 25. So just one higher. And then we're going to repeat. Back down to 24. Back down to 21. Back down to 16. And then back down to 9. And then finally at 12 it's 0. And once again, let me go ahead and draw this. Awesome. And I'm going to leave this one in pencil. This is going to be, but I'm going to label it in pen. This is my imp. And my last one I'm going to draw in pen. And you can kind of see it right there. I'll try to darken in the pencil, make it a little better. Good night. Come on, Tim. That's doing good. Awesome. And then our last one is going to be, read it, is going to be, finally the announcer calls for the last contestant, altruistic. We got Al. What's happening, Al? All good things, altruistic. And what does it say about Al? With your computer broken, you decide to record the balloon's height and distance by hand. Al releases the balloon from the 10-yard line, so he starts at the 10. Boom. And the balloon reaches a height of 27 yards and lands at the 16-yard line. You may be wondering, okay, a height of 27, where do you put it? Well, check it out. If he releases at 10, it lands at 16. What's in between 10 and 16? That'd be 13. So 13 is where it's going to be at its height of 27 yards, which is 25, 6, 7. Boom. Right there. Right. Fall that back. 6, 7. There we go. So I don't even need the other points. I'm still going to use a pencil to draw in case I make a mistake. But everybody see what I did there? We knew it started at 10. It hit the ground at 16 yards. And so in between 10 and 16 is 13 and had a height of 27 yards. So not my best parabola. A little bit better with the pen than I did the pencil, I think. And now we're going to use this to help us see on back what can we figure out. And this is going to take a little longer. You'll have to watch part of this on your own probably, but I do got to finish this up today, and then you guys have the homework for today. So what's our longest distance? Well, our longest distance, let's look at it. Jen went 8 yards. Imp went 2 to 12, which is 10 yards. Meg went 3 to 14, which is 11 yards. And Al, I forgot to label Al, went 10 to 16, which is 6 yards. So the 11 yards wins, so magnanimous. Longest distance is Maggie with 11 yards. Who had the highest throw? Well, that's easy to see from the graph. Who goes up highest? Jen does by just 1.75 feet higher than Meg, which is with 32 feet, or 32 yards. Highest throw was Jin with 32 yards. And then we want to look, and these are all these questions again are up above, but we want to know what are their start and ending values, or their x-intercepts, okay? And what are the x-intercepts? Well, Jin had an x-intercept at 0, 0, and 8, 8, 0. So 0, 0, and 8, 0. What was Imps? Imps was at 2, 0, all the way over here to 12, 0. And Maggie's went from 3, 0 to 14, 0. And then Al's went from 10, 0 to 16, 0. And what do these tell me? These tell me the points where the balloons were thrown, where the balloons were thrown from and landed. Okay, so these are our x-intercepts. And again, you can read up above. On C, it asks us what's the vertex of each graph. The vertex is the highest point of each graph. So let's look at the vertex. For Jin, it's at the point, follow it down, x first, 4, 32. For Imp, follow it down, it's at the point 7, 25. For Maggie, let's follow her vertex down. It's at the point 8.5, 30.25. Remember, that's in our table of values. We have right here 8.5, 30.25. That's how I was able to say it so quickly. Comma, 30.25. For Al, it's at the point 13.27. Sorry, you didn't see that. 13.27. And what does the vertex tell me? The vertex tells me the maximum height the balloon reached. The maximum height the balloon reached. So it's from this I can look and easily go, oh, 32 is the biggest Y value, so that means Jin threw at the highest value. In the same way, I could just subtract the X values of the intercepts to find out the longest distance thrown. All right, so you guys who have homework on this one, 58, you need to make an XY table, find all the points. Maybe start at -2 and go on from there until you find the shape of this graph. You're going to do it just like we did it for Maggie. But this is how we can use an XY table from an equation, how we can just draw a graph, how we can use a table of values, or in Al's case, how we can use the fact that we know the vertex is in the middle to find out what that middle X value is. Okay? All right, lots of connections here. I know it was a big day, a lot of work. Peace out.